Hello everyone. In this segment, we are going to find the equations relating to the product of inertia Ixy for the right angle triangle case number 2. Case number 2 is the case where is the opposite is at to the right side. We have the triangle ABC with base equal to B and height equal to H. And the equation of the line AC is y equal to H over B multiplied by X. We are going to use vertical strip. The vertical strip width is dx and the height is y. And for the expression of dix, it will be equal to the area multiplied by the x multiplied by y. But our x is the x to the CG of the strip, and the y will be y over 2, the distance from the CG to the x-axis passing by line AB. But first, let us examine the area of the strip. The area dA equal to dx multiplied by y, and our y equation h over b multiplied by x. So we are going to use that expression, and we are going to modify the value of dA as follows: dA equal to dx by y equal to h over b multiplied by x. This is the equation of the y multiplied by dx. While for the x multiplied by y multiplied by 1/2, we will adjust that equation. It will become h over b multiplied by x all multiplied by x over 2. It will become hx squared divided by 2b. Regarding the product of inertia for that strip, dixy equal to the dA, which is already hx over b dx, multiplied by hx squared divided by 2b. We are going to readjust these terms. So the dixy equal to h squared divided by 2b squared multiplied by x cubed, again multiplied by dx. Then the ixy would be the integration of dixy equal to h squared over 2b squared multiplied by the integration of x cubed dx from x equal to 0. Our strip will move from x equal to 0 to x equal to b, where b is the breadth. The integration of x cubed dx will be x to the 4 divided by 4 inside bracket multiplied by h squared over t2b squared. We are going to substitute from 0 to b. Then the ixy expression will be equal to h squared divided by 2b squared multiplied by 1 over 4, open bracket, b to the 4 minus 0. Then at the end we'll get our expression as h squared b squared divided by 8. Now suppose we want to get the same result by using different technique, by using horizontal strip. Is it possible to have that expression? The answer is yes, and we are going now to make the same brackets by using horizontal strip. In order to use the horizontal strip, it is apart by x distance from the y-axis. Then the remaining length of the strip this time will become b minus x, and the height will be dy. Again, our dixy will be equal to the dA multiplied by x multiplied by y, but x and y relating to the CG of that strip. For example, in our case, the middle of our strip, which is 1/2 b minus x, will be added to the x. It will represent the x distance of the CG to the y-axis, while the y distance will still be the same. Our dA will be equal to b minus x multiplied by dy, and the dixy will be dA multiplied by y multiplied by x plus b minus x all divided by 2. After making adjustments, we will find out that dAixy equal to b minus x multiplied by x over 2 plus b over 2 multiplied by y dy. Adjusting the terms and deleting the corresponding the terms like bx over 2 minus xb over 2, they will cancel each other. Then we left with dIxy equal to b squared minus x squared over 2 multiplied by y dy. Since we have the expression of y equal to h over bx, we will get an expression for x this time as x equal to yb divided by h. We are going to square that x and substitute for the place of x squared. So dIxy equal to b squared over 2 minus b squared y squared over 2 h squared multiplied by y dy. Since we are integrating in the y direction from y equal to 0 to y equal to h, so we have to cancel any trace of the x by substituting by the value of the y. So we get b squared over 2 multiplied by y dy minus 1/2 b squared y cubed dy divided by h squared. We are going to make integration for the first term, which is b squared over 2 by y dy. It will become y squared divided by 2. And for the second term, which is minus 1/2 b squared y cubed dy over h squared, it will be y to the 4 divided by 4. We are the same expression in the next slide. The integration of dIxy equal to the integration from 0 to h of b squared over 2 multiplied by y dy minus 1/2 b squared multiplied by the integration from 0 to h of y cubed dy over h squared. The integration of dIxy will be ixy, and the b squared over 2 will be a common factor. For the first term, y squared over 2 from 0 to h minus b squared over 2 multiplied by y to the 4 divided by 4h squared. When we are going to substitute when y equal to h, then we have b squared divided by 4 multiplied by h squared minus b squared over 2 multiplied by 1 over 4, it will become b squared over 8 multiplied by h to the 4 divided by h squared. Adjusting the terms, we have b squared h squared divided by 4 minus b squared h squared divided by 8. So we have at the end that Ixy equal to the b squared h squared divided by 8, which is the same result as per the previous calculation using vertical strip. Thanks a lot and see you. Goodbye.